So today you can see we're just going to be going over this stuff in a little bit of detail. Some of this is not immediately obvious. We'll talk about this disco when we get to that. Some of the stuff you didn't learn about. So it's going to be extra knowledge, but it will come up later. Okay, not going to spend too long on this. Stem and leaf plots, you should have read about those last night. The stem doesn't have to be just one number. So if you have a 5-digit number and you want the first 4 to be your stem, you could have 4 digits right here, and then your leaf is just the last digit. All right, so keep that in mind. You're creating or examining your stem and leaf plots. Now this is limited. It's great because you can still see the data. You know that there's a data point that's 54 in this. You know that there's one that's 43. But you know, if you have too much data, it's not going to be useful to try and use a stem and leaf. That's just too difficult. Technology can do it, but you're not going to do that by hand. All right, dot plots. These are very handy in class. We will likely use these quite a bit. And it's good for collecting data. So, you know, if I can figure out a way of having you guys do a project this class, then you might be collecting data and using dot plots. Again, its usefulness is limited if there's too many cases, because it's a lot of dots. You're not really gonna, at that point, the next one works a little better, a histogram. Okay, so with a histogram, you lose the individual data points, but it's really great for if you have a large data set. And the quantitative data are separated into equal width bins. The y-axis, and you can see the difference between these two down at the bottom. It can be just a straight up frequency. How many are in this bin? Up to almost 25 here. Or it can be a relative frequency. Of course, what you lose with a relative frequency is what we know right here is with this one, this bin is almost 25% of the total, but without other information, we don't know how many data points are in that. So it can be good for depending on what your analysis is. Now, traditionally, the interval only includes the lower value. So, like, let's see here, this 2.5 to 3. So right here, it's represented by this really small bin. The value 2.5, if you happen to get that, would actually fall in the bin on the right. It would fall in right here. But the value of 3 would fall into this bin, not this one. Okay, so just keep that in mind. Those are special cases, but it's good to know that. And there it is. If the value falls right on the line, put it in the bin on the right. And this is the other thing. And there are some problems in your homework tonight where this will come up. If you are creating a histogram, you want to make sure you have a good number of bins. And around 10 is good, but you don't want it to be too many. Like notice right here on the right, there's only 3. You can't get a very good feel for the shape of the data with just 3 bins. But then if you split this up into however many that is, you know, the bins are so small that there's a lot of gaps. So there's just no data between 73 and 91, it looks like. So it's just not useful to split it up that small. Your calculator will, if you create one on your calculator, it creates the gaps for you. And there are some things there. If you run into problems, we can talk about that more. That might come up in class. But just in general, keep that concept in mind. So just to talk very briefly about histograms versus bar charts, this is the key thing. This is the main thing. Histograms have a natural order. So meaning this is petal length and it starts at 0, goes all the way up to 7. You can't just decide to take this bin right here from 5 to 5.5 and move it over here because there is a natural order to the way this distribution has to be laid out. But on the right, when we're talking about races, there's no natural order that this needs to be in. I know they put it in order from the highest to lowest representation, but you know, if the Hispanic portion went up, then all of a sudden the Hispanic bar would be moved up to the front. So if it was a histogram and we were collecting data, we wouldn't be moving those around. So that's just one key idea. So you can see bars and bar charts can be placed in any order. Bars are connected, but not in bar charts. Sometimes that rule is not followed, but it's good practice to do it that way. And of course, when we're talking about histograms, that's quantitative. When we're talking about bar charts, it's got to be categorical. And that leads to the idea, chapter 3, which we studied yesterday, those were all displays for categorical data. Chapter 4, we're talking about today, this is all displays for quantitative data. So everything we talked about is quantitative. And now we are going to talk about DISCO. So this is just an acronym to help remind you how to describe a histogram. So the DI right there at the beginning is your distribution. The S is spread, C is center, and O is outliers. Okay, and there are other acronyms that can be used. If you look online, there are people who use CUSS, C-U-S-S, as a acronym, SOCS, S-O-C-S, all kinds of different things. I think for me, DISCO is just the one that's always going to make sense, and I'll remember that way easier. So we'll talk about these in detail. So for your distribution, I'll just bring up all the pictures as well. The shape can be unimodal, like in the top right. The mode is the value or the bin with the highest frequency. So of course you got your one mode right here, and you could have a bimodal. You can see we've got, looks like 2 humps in the data. Now, it doesn't necessarily have to be the one bin, but just look where there's a hump in the data. There's only 1 in the top right. There's 2 right here. If you have more than 2, you call it multimodal, which is not a normal situation. That might never come up, but it is called multimodal if there's 3 or more. Uniform means there's no real mode in the data. So you want to use one of those terms when you're describing the distribution. You also need to describe if it's skewed or symmetric. So if it's skewed to the left, that means the tail is being pulled to the left. And that means it's pulled in the negative direction, so it's sometimes called negative skew. If it is positive skew, it's skewed to the right, and you can see the tail pulled off to the right. Now, if it's symmetric, well, it has symmetry. It looks about the same either way. And I will say there are some times where, you know, if there's like a small dip and then it comes back up, depending on the total shape of the data, you might still call it unimodal. Maybe there's some reason that we just didn't have enough data points to fill in that gap, you know? So, you know, it can be tricky sometimes. Just get some practice with it. That's what you have in your homework. The spread, this is what we're going to come back to in more detail later, but it's worth just doing a brief overview. The 2 main ways of discussing spread is going to be using standard deviation or IQR, interquartile range. If the distribution is symmetric and unimodal, I should also say if it's uniform, you can use the standard deviation. If the distribution is not symmetric or not unimodal, use interquartile range. And we will talk about the reasons why in a little bit, but you know, it's going to be something to keep in mind. The most basic measure for spread is the range, but this is very limited in its usefulness. So if there's no other information available, and if you stick around at the end of class, I'm going to go through some problems. We'll see something like this. So if no other information is useful, if no other information is available, then you can use the range to describe the spread. Okay, and that's of course just the max minus the min. All right, actually I wanted to go back real quick. You can see right here, this is what we're talking about with spread. If you don't describe this, then someone just reading won't know if we're talking about a distribution like this on the right, where it's got a lot more variation in the data, than the one on the left, where it looks like they all kind of center around a value. So there we go. Any questions on this so far? Okay. So the center, there are 2 measures of center. Again, if the distribution is symmetric and unimodal, or if it's uniform, use the mean. If the distribution is not symmetric or not unimodal, use the median. And I should add, I'll draw in here, you can have a symmetric bimodal distribution, which would look like this. So you'd say that's symmetric. I didn't draw it very well, but you would say that's symmetric, but bimodal. So we wouldn't want to use mean and standard deviation. We'd use median and interquartile range. Okay. And this is just a point about notation here. The mean is the average, and we frequently, just in general, will refer to this as X bar with a bar on top. But the notation you need to understand is that a bar on top of anything is going to be a sign that it's the average is taken. So if I was getting the average height of all of the students here, then my variable would be height, and I could put a bar on top of it so that you would know as statisticians that, oh, that's the average height. All right, you will see that quite a bit. It's going to be important to know, and you'll learn other notation that's special for stats as we go through. Okay, median is the middle value. If there's an even number of data points, we're going to average the middle two values. I'm going to show you how to find this on your calculator. In fact, you're going to always use your calculator to find this stuff. Don't even waste time, doing the stuff by hand. Okay, and you need to include the units when giving the center. Okay, and this is, it's surprisingly easy to forget to do that. So just keep that in mind. The mode is technically another measure of center, but I'll tell you, we pretty much never use it. We talk about things being unimodal or bimodal, but we never talk about the mode being X value. We say it's the median or the mean. All right. So what I want you guys to do, and this is where you are going to actually annotate on the screen, given this distribution, I want you to identify where the median and the mean may be. I'm going to first of all identify that this is the mode. Okay, you can barely read that, but that's the mode. So I want you to identify where the median and the mean might be. And what I want you to do is just draw a vertical line, and then where you put the mean, put an X bar next to that one. So I'm going to get a lot of lines on here, but we should see them kind of come together in a certain spot. All right, I'm seeing some lines. Everyone can annotate, kind of show. I know it's going to get a little bit messy, but we should see some kind of order. All right. So I'm seeing. All right, so we can stop there. And it looks like a lot of stuff centered right there. And the way this is labeled, it looks like you're calling this the mean and this the median. I don't know if you meant to do that or not, but that's how I'm seeing it. And these are flipped around from how they should be.
All right. That's what I was about to say. I thought it was the other way around.
Okay, there we go. So we will show this real quick. So the median is only slightly pulled in the direction of the skew. So what I'm going to do, I will erase all this stuff real quick. Clear all the drawings. So yeah, if this is our mode right here, the median is going to be pulled over a little bit for sure. So I'm going to put median right there, but the mean is going to be pulled over quite a bit. The mean, you can think of it as the balance point for this. Imagine this was like a tray of food or a tray of stack of coins or something. Where would you put one finger so that everything would balance perfectly? It'd have to be over here somewhere. I don't know exactly, but that's where your mean would be. And you can see when you think about what the mean is, so your X bar is going to be the sum, okay, I can't write very well, of all your X values divided by the number of data points. And so if you have one data point on this distribution, if we had a climate sensitivity of 20, which is way off the charts, right? But if we had 20, then that would throw off our mean big time. We'd have to add that in and divide. And that would cause our mean to be pushed over way further. But the median might only tick over just a little bit, you know, because we added one more data point, so we just need to move the median over by 1. So the median is resistant to the direction of the skew, but the mean is not. It's going to move more. And you can see the very last note there. The median is a preferred measure of center when the data is skewed. All right, any questions on that? All right, so let's look, what's next for us? Outliers. Pretty straightforward with outliers. You just need to make a note of it. Like if I was describing this distribution on the left, I'd say it's unimodal, fairly symmetric. It seems to have a center around 9.25, whatever y is. I don't know what that is, but anyways, you get the idea. But then when I was talking about the outliers, I'd want to say there appears to be an outlier at about 9.45 with a gap from 9.35 to 9.45, you know, guess what those numbers are. Okay, and that's all there really is to say about that. And make note of it. You don't fail to mention it, but you don't have to go into great detail with gaps and outliers. So that's DISCO. And again, that acronym just reminds you distribution, spread, center, and outliers. Okay, the box plot now. Now you can see in this diagram, it's also being referred to as the box and whisker plot. But typically people just call it a box plot. And this has a lot of information in it. We're going to talk about that more in next chapter. We're going to focus on just some of the details. It loses the distribution shape. So you can take that same distribution data that we saw in one of the previous slides, and you can turn it into a box plot. And it gives you a really good feel for the data, but you don't see the actual shape of it with the heights of the bars anymore, the heights of those bins. But you can still get a lot of information. It's pretty quick to make, and it's really good for comparing multiple data sets. It's actually better than histograms for this. The 5-number summary, we've got the min, the first quartile. So in this case, in a normal box plot, the min is the end of this whisker. We actually have an outlier, so the min is actually this one right here. The first quartile right here, the median, the third quartile, and you can see that, of course, how they have it labeled. If we didn't have a far outlier on the other side, then this would, or that's just a regular out. Anyways, if we didn't have an outlier here, that would be the max. But we do have this outlier, so technically that's our max. And again, that's more stuff that we're going to study next chapter, but good to know. And the interquartile range, you should have read about this, is just your third quartile minus your first quartile. And just to make sure this is really clear, when you are finding the median and the first and third quartile, we're going to do it with a calculator, but the way you would do it by hand is line up all your data values from the smallest to the biggest in order. You find the middle value, you know that's the median, but then you take the lower half and you find the median of the lower half. That's your first quartile. Then you find the median of your upper half. That's the third quartile. So it's a median of a median, or a median of a half. Okay, so conceptually that makes sense. It's not worth the time for you guys to go and create that yourself. So this is where you're going to use your calculator. And I'm going to come back to this screen. Don't worry about doing this right now. Don't even write these numbers down. I'll share this again. But I'm going to come back to our chat. And what I want you guys to do, you might find it helpful for right now if you're in gallery view. If you find my screen, you can pin my video to the front just so you can see what I'm doing. So you'll need your calculator. And I'm going to be doing something awkward, looking down at my iPad to see what I'm doing here. So there we are. Of course, you want it on. Okay, mine is on. The first thing I want you guys to do is hit 2nd and 0. And you're going to pull up a catalog that looks like this. All right, and if you are in alpha mode, you can hit D, or just scroll down until you find diagnostic on. So I'm going to do that myself. There's diagnostic off, diagnostic on. I honestly don't know why it doesn't just come prepared, but you always have to turn this on. So once you find that, just hit enter. And then you can kind of see it says diagnostic on the main screen. I hit enter again. And it just says done. And what that does is it turns on some extra functionality in your calculator for when we do regression analysis later. And you've done it, you're good for the year unless your calculator, I don't know, something happens. The next thing you're gonna do, this is another quick check that everyone needs to do at the beginning. You are going to hit second and vars. So second, and then vars is right here next to the arrows, and you pull up this menu. You will learn about this menu, but what I want you to do is just click on normal CEF option 2. And when you do this, let me make sure this is showing up well enough. You should see a menu like this. If you do, you're good. You can just quit out of that. You don't need to do anything right now. I just want to check that you're seeing a menu. If instead, if you're seeing on the main screen, it just says normal CDF open parentheses, and you don't have a menu, chat, add something in the chat to let me know. Because in that case, you will need a firmware update. Okay, so yeah, if you do see that menu that looks like this, you are golden. You got nothing to worry about. If you have a newer calculator, your menu is going to look a little different, but you need to see the menu. Okay, I will move ahead, and I'm hoping that this doesn't describe anyone, but it could be the case. Okay, so finally, let's actually do this problem. I'm going to show you what to do, and then I'll go back to the data so you can plug it in. So I'm going to go back to the main screen right here. You can see it's kind of awkward for me to show you how to do this stuff on calculator, but I think it's good for today. All right, this stat button is right here. You want to click on that. And luckily, all you have to do is hit enter. That edit is what we want. And I've already put my data in, but you can see you're going to pull up lists that are potentially blank. Maybe if you got this from the school, someone left something from last year. But you should have a bunch of lists. And first of all, if you just a good thing to know, if you want to clear the list, all right, you can go up. You can not really see very clearly what I did, but you can go up and down the list. If you go up to the top where L1 is highlighted, you can hit clear and enter, and it will clear the list completely. You don't want to delete the list, though I can show you what to do if that happens. It's not the end of the world. So from here, you're just going to put your number in, enter, put the next number in, enter. So I'm going to pull up that presentation screen. And then I want you to enter the data. And here it is. All right, so take the time to put those in. So that, so you should be able to find the 5-number summary. Based on that, I'm going to pull up the presentation again. Okay, sorry. So there's the numbers again with that, putting the list in, stat, calc, and then one variable stats will give you all of this information. We can just write it in. I'm going to assume you guys put the numbers in correctly. I'm going to assume I put the numbers in correctly. And I think, if I'm right, that the min was 1, the first quartile was 17, the median was 31.5, the third quartile was 54, and the max was 98. If I'm off, it's because I made a mistake in the data entry, But if all your numbers match, I think it's safe to say that that was correct. Okay, so don't try and calculate this stuff on your own. It's not difficult mathematically, it's just time consuming to put these numbers in order. And when you have data sets in the homework, just create it, put it in a list. Okay, any questions on this? Okay, so the next one, standard deviation. I am not going to try and explain standard deviation. I will say that on the calculator menu, when you did the one variable stats, it gives you the standard deviation. Now, I'm not going to unshare, but if you scroll up, you're going to see this number. I can't quite see it, but it's S sub X. It's the fourth one from the top. That is your standard deviation. So one variable stats gives you that as well. That's really good to know. The only thing I'm going to talk about with standard deviation is we're going to talk about the formula a little bit. S squared is your variance. And that's kind of showing the total variation in the data with all the data points. Page 60 to 62 in the textbook kind of gives more details on how to do this calculation by hand. We're never going to do it by hand, so I'm not going to take the time to do that now. The standard deviation is just the square root of variance. And underneath the radical, this is exactly the same as what you see here. It's just shown a little differently with the values there, but it's the same. The one thing I did want to talk about is this n minus 1. Why is it not just divided by the number of data points? Why is it n minus 1? And they talk about that a little bit in the textbook, but it's not important in the sense that it's going to show up on the AP test, but I think it's good to know why. If we divide it by n, then what that does, it gives us a smaller standard deviation. Think about it. If we, instead of dividing by 20 data points, we divided by 19, that's going to serve to actually make our standard deviation a little bit wider. And we need that kind of buffer widening the standard deviation because most of the time we're dealing with samples. Well, and this is our sample standard deviation. We don't have enough accuracy in our data to be able to say that that's the standard deviation. So we want to widen it a little bit to make it match the population a little better. Okay, so I know that hopefully that's helpful a little bit, but using n minus 1 just widens the standard deviation a little bit. Okay, that's all I'm going to say to that effect. So the last couple of charts are weird ones that were not in your book. The ogives will appear later, and it is pronounced ogives. They're called cumulative frequency graphs or charts sometimes. And it's useful for answering certain types of questions. I'm not getting into it right now because we're not going to be seeing those questions till next chapter. But here's the way it works. As you start from your lowest value, from your min to your max, you're going to show like what % of the data cumulatively are we finding. So 50% of the data, we start over here at 0.5, come over. 50% of the data falls below 0 theta. 50% of the data is above that. But now, 50% isn't that difficult, but 80%. So if I came over here to 80%, then that tells me if I come down perfectly, that's about 1/3 of a theta. So it looks like 1/3 of a theta and below will capture 80% of our data. So it's cumulative frequency. It's important to be able to read it. You will never create one of these. And we will have some practice problems next chapter, but I wanted to introduce it now. And the last one, funny enough, this is actually the same chart we looked at yesterday, but just looks prettier. I just picked a random time plot and I didn't realize that it was the same data. But yeah, you can see kind of, we were looking at this stuff the other day. So a time plot is just a scatter plot with time as an x-axis. So, if you have time, it's a time plot. And it is good for seeing change through time. It's actually one of the most common types of graphs, but funny enough, not one that we deal with a whole lot in our class. Though, again, be able to kind of read it and understand it. And that is really all I wanted to cover today. We actually did pretty well on time. This is your homework. I will say something about the homework here. I think there's 11 problems tonight, if I kind of write, 12 problems last night. And I know that sounds like a lot. The whole idea with homework is that you should do the homework until you've mastered all the stuff that you need to know. So if you have 2 problems that look very similar and you're like, I totally understood that last problem, I'm not gonna be collecting it, at least not right now. So, just make sure that you feel comfortable with it. So I tried to pick a lot of different types of problems, which is why there's so many. So look through all of them, and if it's something you don't know how to answer, then take the time to work through that and get it figured out. It's up to you to keep caught up in this class. I'm always going to be available for help if you need to schedule some time with me. Make sure you read chapter 5. We are going to go over most of it tomorrow. And I think that means Thursday and Friday we might have slightly shorter classes, though no guarantees until we get there. Anyways, that's your homework. If you want to stick around to go through some problems, I just have 4 problems picked out from the homework, or like problems from the homework, I should say. And you can hang out to go through those. If you feel like you understand it, then you can maybe watch this video later and just watch the homework help. So with that, if you are taking off, goodbye and have a good day. Okay, so with these problems, the first thing that I do is going to take the most time, and the rest of it goes pretty fast after that. Describing a distribution is actually a kind of a time-consuming thing. You have to write a little paragraph about it, but this is where I'm going to remember disco. Oops. There it is, sorry. Okay, and one thing that I didn't really talk about as far as disco goes is that you want to include the context. So we start with the distribution. So you can say, and you have to write full sentences for this. And I'm going to use some abbreviations as I go through, but that's a T. The distribution of, what's our context? Average drive distance for professional golfers. Now I'll just kind of say that. I could put a little bit more as far as context goes, but I'm just going to move ahead for time. The distribution is, and now I can start describing the distribution. It seems to be, when I look at that distribution in the top left, is unimodal. And I would say pretty darn symmetric. So that is the distribution. That's all I need to say. I'm going to skip to the center real quick. And for the center, because it's unimodal and symmetric, I'm going to talk about the mean. The mean is between, because I don't know an exact number and these bends are 5 wide, I know it's going to be between 285 and 290. The mean is between 285 and 290, and I need to put the unit, so yards. There's the center. Okay, I will talk about the spread now. I don't have any information. I don't want to estimate the standard deviation, though later we might be able to. There's a way of doing that. I don't want to estimate the interquartile range. So without anything else, I'm going to say the range is all I can talk about. The range is about, about 65 yards. And what I mean by that is I know the lowest value is going to be around 255. And the max is about 320. So when I do that subtraction, that's 65 yards. And that's good enough for range. We don't have anything else to say. And finally, the outliers. I'm not sure I'd call that low one an outlier, but I do want to note that there's a gap. So I would say there is a gap from 260 to 265 yards. And as far as I'm concerned, I think as far as any AP reader is concerned, that is describing the distribution really well. You've covered all the important stuff. So hopefully that's good and helpful. Okay, so if there are no questions, so approximately what proportion of professional male golfers drive, on average, less than 280 yards? Now, this is one that we're going to actually have to do a calculation. Luckily, we already know there's 202 golfers in this data set. So all I need to do is figure out how many drove 280 or less. So this group right here. And this is where we're going to have to read the frequency on the left the best we can. So it looks like only one golfer is down in this group. And just guessing, I would say, is that, I don't know, 3 in that group right there? Maybe 4 or 5. And this is, we're looking for approximate, so you want to be in the ballpark. So if I said 5 right there, we can go with it. The range from 275 to 280 has 20, I think. So hopefully you can read the 20. If I add that all up, 20 plus 5 plus 3 plus 1, that's going to be 29 golfers. Out of 202, there's my proportion. All right. And you can calculate that. So estimate the mean. We already did that to some degree. We know it's going to be between 285 and 290. We can go a little further than that with this problem. Because it's so symmetric, I might even guess that it's right in the middle of this bin right here. So I might even guess the mean is 287.5 yards. I'm kind of covering up other stuff, but you know, it's a guess. We don't have the data, so we're just gonna, you know, that's a reasonable guess right there. And finally, do you expect the mean to be smaller than, approximately equal to, or larger than the median? Now, because this is unimodal and symmetric, that means the mode, the median, and the mean should all be about the same. So these should all be approximately equal. Okay, so like I said, the first one takes the most time. After this, it goes a little faster, especially when we get to the next 2 problems. Those are really fast ones. All right, I'm going to clear all this writing. If you're trying to copy that, this is on a video, so you can watch it later. All right, so they give us in the next part the standard deviation and the quartiles. So when we're talking about this, we're going to write a sentence or 2 describing the spread based on the quartiles. So this is A1. I can say, we didn't really talk about it, but it's in the chapter. 50% of the data falls between the first and third quartile. So we can say 50% of average golfer drive distance. Golfer drive distance will fall between 282 and 294 yards. That's all you need to say. It's showing that you have some conceptual understanding of what the interquartile range is. The standard deviation, a little bit trickier. And I encourage you, look up the problems in the back of the book where the answers are, just to make sure that you're answering it in a way that makes sense. But what you might say here is that the difference between the mean drive distance and a typical pro golfer is 9.3 yards. Again, you know, the interquartile range is a little bit more simple. I don't know if that's the right word, but it makes a little bit more sense how you describe it. So for standard deviation, you just kind of describe it as like, this is the average difference that people will have from the mean. Okay, do we have any concerns about using either of these? No concerns, but if we have unimodal symmetric data, standard deviation is the better choice because it's more robust. Okay, any questions on those? All right, let's look at these two. These will go a lot faster. I'm not going to create an entire stem and leaf display for number 36, but it does want us to create a stem and leaf. And remember, we can use any number of digits for our stem, so I'm going to use the first 2 digits. Luckily, this is already in order. If you see, it starts at the highest and goes down to the lowest. So I know I'm going to need 150 down at the bottom, then 160, 170, 180, 190, 200, 210, and 220, which is as high as it goes. Now I can just start adding in the leaves. So I'll just do the first 2. So for the 150s, I have 152, 153, 153, 156, 157. And of course, that's coming from right here. If I'm looking at the 60s now, 160s, I got 160, 160, 162, 167. And the key thing to keep in mind is that you want to make sure as you're writing these numbers that these are lined up on top of the other so that it forms nice columns as you're going along. That way it'll have a good visual display. And then you can describe the distribution from there. All right. So the last one requires the least, and I don't even think I'm going to write anything down. Actually, I'll leave that up just in case you guys were looking at it. All right. So the last one, after receiving many complaints about his final grade histogram from students currently taking a statistics course, the professor from exercise 43, you can read that one in the book, distributed the following revised histogram. Comment on his display. All right, and the commentary that we're thinking here is that he chose a bin width that's too small. This, you'll notice that right here, the highest, the mode of this data only has 4 people in it. And you'll also notice that there is a lot of gaps in data. We really don't want to see that with histograms, and that might just be the end of the data here. But we really want to see a nice, smooth data, collection of data. So if we see a lot of gaps, that's not a good choice of bin width. So that's kind of the thing you should be on the lookout for. Look, is it too narrow or too wide? Okay. And that was really all I was going to go through for right now. I will hang out if you guys were needing to ask me other questions. Let me just